Good morning, and my name is Dr. Randy Price, and I'd like to go over with you some of the stuff we've been doing at the LSU Ag Center, where we've been developing some new ways to analyze some of the patterns from manned aircraft and sprayer drones. Do note we also have a long distance patterning system we've been playing around with, and I'll say a little bit about that right now. This system uses the string and vision analysis system that we've talked about that at previous meetings. We just have this platform where we have a box with a laser, a green line laser that goes through it. It hits the string, it directs the string through the box. There's a GoPro that does the recording for us. You kind of turn it on at the same time you turn on the string pull. And then there's a counter so we know what the distance, and we just use a drill and a counter wheel on the drill chuck if you get the metal ones that are knurled. And you just put the string in between that and it'll actually pull the string in at a constant rate. The one thing we did add for long distance analysis is this vacuum in the bottom, and we have this working pretty well. I use this all the time. So we have some electronics where it turns the vacuum on, and that's actually our string collection system, because one of the problems we had is you start collecting several hundred feet of string that you threw across a field and the guy flew over it like 5 times, and you're checking the multipass, how well it interfaces. You quickly run out of reel space and stuff and have to deal with a lot of string. So this vacuum works good. We can actually hold about 3,000 feet of string in this vacuum. To do long distance testing, we need 3 different components or 2 different ones. We have that string analysis system, which you see back here on the left. Next to that, we still have the string tensioner, but we set it right next to where we're going to pull the string in. We then have a drone over here on the right, where we have a little mechanism that we attach the string to it. We fly the drone up over the crop. We drop the string, fly the drone back and land it. We move the string from the tensioner, attach it to the analyzer, and then we pull it in. Here's an example of the dropping system. Nothing fancy. We just buy this off the internet for whatever drone we have. We had a Mavic 2S in this case because one of our older drones. We haven't had any problems with the string getting caught in the propellers. Although we did, mainly take off from an elevated position like this tunnel cover on this truck. The string seems to be heavy enough that it stays above the drone. We weren't trying to do 3D type flying with the drone, mainly just fly it up over the crop at a steady increase in height. Here's an example of the string in the crop. I don't know if you can see it, but let me see if I can highlight that for you. There it is right there. So it does lay a little bit in the crop, and we'll address that a little bit. How that might affect your droplets caught on the string here in a little bit. So here's the camera system, or the winder in action. I'll start it so you can see it. And remind you, we're winding up a couple hundred feet of string here. I don't know how much it will do. 300 will go through. It might get harder at that point. And there it is going through the crop. Here's that same software used to analyze that. Basically, this is a whole pattern for several hundred feet. That was like 10 passes with the drone. You can see how it records everything across there. We can actually take that pattern just like a single pattern, run it over on the left, the bottom left of this screen where we have the adjustments for swath width, and you can run that out to several hundred feet and actually wait till those patterns touch, and then you'll get the CV for that whole multipass pattern. So it's pretty slick. Here's an example where we tested that to show you kind of how it helped us out. We had a drone we were testing. We were trying to get the effect of different speeds. So this is one where we flew over that with, I think, 11 miles per hour and 18 miles per hour. The top graphs were for 11 mile per hour speeds. The bottom ones for 18. My face is covering up part of that. Sorry about that. But if you look at the bottom ones, it is less material because these drones are locked in for the same application rate, but it does look quite a bit more even, because on this testing system, on the string one, we kind of read drops or individual places on the string. So these blue droplets are like drops on the string. So if you look up above here, there's multiple heavy spaces where it's real heavy and then lighter. And we thought the bottom one actually looked better. So that's kind of what we're using this system for. A few notes about the problem. We didn't really have any problems with excess dye getting on the string. Most of the testing we did, we threw the string at about 250 feet. The testing was only about 180 to 200. So there was leader string on the opposite side of the field. When we pulled that through, we never caught any extra dye on that. We did give it a minute or two to dry, which maybe helped out. You know, we had to land a drone and then reel it in and stuff like that. We did test in areas over and over and over, multiple days. It didn't seem to matter. We never built up enough dye that it ended up on the string, you know, that when it wasn't supposed to be there. So in conclusion, we tried to show you two different systems we've been using over here in Louisiana, you know, to kind of help testing and do some different testing that we haven't done before. One of them's a paper and dye pattern analysis system. They do sell one, but we kind of showed you here. You could probably build your own. I may try and put the software somewhere on the internet if people decide they'd like to have it, you know, the analysis software. It did work very well for sprayer drones. It's one of the ones I use mainly right now for testing them. And I may try and move that full size manned aircraft. It'd be kind of interesting to see if you could do that. We did show you an example of the fluorescent dye patterns testing system where we use that for long distance multi-pass testing over actual fields. We know it works for 200 or 300 feet. You may go out further with it. I don't know. It may get too hard to pull in. We haven't really done any testing. One thing I was going to mention, the crop effect on laying the string on top of the crop. We did notice that it was hard to get a CV below 25% or 0.25, which we have in the past gotten them, you know, below that on the drones. So we do think the leaves kind of may interfere with what actually gets on the string, but we do know, we see the differences, like as we vary swath width, we can see where they're not lapping over enough and where they are. And my comment on that would be, we need to do some research in that area because we know plants are three-dimensional. So the CV may actually be what we're getting inside the plant canopy or just partly into it. And that may just be what we really get in real life when we spray things. All right, if you have any questions or comments, you can email or call me. I probably can't be on this recording, and I apologize I couldn't be there. I got a call Saturday, one day ago, that I was going to have to be out doing a sugarcane test, and the guys harvesting it, which we have hired harvesters that come in with a group. They are a week ahead of time, and they were supposed to do it over Thanksgiving. They said they're showing up on Monday. So I have to be out there for that testing to do that. So I apologize for not being there. If you do have any questions, you can ask Brad Fritz, or you can call me up or send me some email. Okay, thank you.